Well, what can you do with functions? The good news is a lot. You can add them, you can subtract them, you can multiply, you can divide. Now, as we go through examples of this, we're going to talk about that division. If you divide two functions, we're always going to probably see something like that, some type of restriction. Why do you think that is? What's the only thing you can never, ever, ever divide by? Is 0. So we want to make sure that when we're dividing, that we're not dividing by 0. That's usually not something you have to worry about when you're working the problem, but it will come up later in the class. So we're given two functions here, f of x and g of x, and we're asked to add them, to subtract them, to multiply, and then divide them. So let's look at how do you add them. Well, really pretty easy. We're going to take f of x, and we're going to add g of x. And then if there's like terms, which there are, we're going to collect like terms. So we have x plus x, that's 2x, and 4 minus 1 is 3. That's it. Again, you're not trying to solve, there's not factoring, you're just adding two functions. So how would we subtract them? The same way, it's just that when you subtract something, you have to make sure that you're subtracting all of it. So I'm always careful, and I'm going to put a minus and then a parenthesis, and then I'm going to write down what I'm subtracting. And in the next step, I'm going to distribute that minus sign. Now we can again collect like terms, but this time the x's add to 0, so we'd have no more x's left, and we have 4 plus 1, which is positive 5, and that's our final answer. So how would we multiply them? Well, we're going to take f of x, and we're going to multiply by g of x. So we're going to have just a lot of multiplying here. So let's take it a step at a time. I'm going to multiply those two terms together, then those two, then take those two, and then last with the 4. And then we need to come back and collect like terms. That's all there is to it. I think the division you will like because I think it's the easiest. If you want to divide f and g, we're going to draw a division line, and we're going to put f on top and g on the bottom. And you stop. That's all there is to do it. Okay, so you can add, subtract. On the subtraction, you want to make sure you distribute the minus sign. On the multiplication, you just want to make sure you multiply all those terms out and collect like terms. Now, how can it look like if we're putting in numbers? F plus g of 3. Well, there's a couple of different ways. You could add them together, or first with the x's and then substitute in 3, or we can substitute in 3 and then add those answers together. So I think that's what I'm going to do. I'm going to find f of 3, and if you recall, everywhere there's an x, I'm going to put a 3. So we have 9 minus 9 plus 1, which is 1. And then I'm going to find g of 3, which is 2. And so f plus g of 3 is the same as adding f of 3 plus g of 3. So f of 3 is 1, and g of 3 is 2. And we just so happen to get 3. Again, purely coincidental. So we can do the same thing with subtraction. So I'm going to find f of negative 1 first, then I'm going to find g of negative 1, and then I'm going to subtract those two answers. All right, so we're going to go to the f function. So I have negative 1 squared minus 3 times negative 1 plus 1. Then here I'm going to go to the g function. So I have negative 1 minus 1. And now I want to put those together. So f minus g of negative 1 is the same as f of negative 1 minus g of negative 1. So I have 5 minus a negative 2, so I have positive 7. Right, here's how I want to do some multiplication. So just to remind ourselves that f of x is x squared minus 3x plus 1, and g of x is x minus 1. So I want to find f of 2, which is negative 1, and I want to find g of 2, which is 1, and then I want to multiply that together. So f times g of 2 is the same as f of 2 multiplied by g of 2. So that's negative 1 times positive 1, which is negative 1. Right, so how about that division? So again, I'm going to find f of negative 2. And remember, our f function is, we have it squared, and then negative 3 times the negative 2 plus 1. Then we have g of negative 2, and remember g of x was x minus 1. And so I want to do that division. F of g of negative 2 is the same as f of negative 2 divided by g of negative 2, as long as that divisor, what you're dividing by, ends up not being 0. And since we don't have 0, we're okay. So f of negative 2 is 11, and g of negative 2 is negative 3. And you can leave your answer like that. You could write the negative on top of the fraction, or very carefully you can write the negative in front of the fraction. It doesn't matter as long as it's negative somewhere. Now look at this problem. What in the world does that mean? You need to break it up. So we want to find f of 3 and g of 2. And then the numbers on the outside means to multiply that by. Right? So let's go ahead and find f of 3, which I think we did up in the first example. So we have 9 minus 9 plus 1, which is 1. And then we want to find g of 2, which is also 1. That's kind of nice, but might be confusing. So we go back to this expression. So this says to go 2 times f of 3. Well, f of 3 is 1. Minus 4 times g of 2, which is also 1. So it just is a funky looking kind of problem. You just have to be able to read it. So we have 2 minus 4, which equals to negative 2. So let's go back and look at this problem one more time. It says to multiply 2 times f of 3, then minus 4 times g of 2, right? So 2 times f of 3 minus 4 times g of 2. Just take it one step at a time. Okay, what does this example say to do? Well, we want to find g of negative 2. We want to find f of negative 1, divide those, and then raise that to the third power. So let's find g of negative 2. Remember that function is x minus 1, so negative 2 minus 1 is negative 3. Then f of negative 1, so we're going to go back to the f function. So we have negative 1 squared minus 3 times negative 1 plus 1. So g of negative 2 is negative 3. F of negative 1 is positive 5. And then I need to cube that, or raise it to the third power, which means I don't multiply by 3, but multiply itself 3 times. So this is negative 3 times negative 3 times negative 3 is negative 27. And then 5 times 5 times 5 is 125. And that's your answer. So that's what you can do with functions. You can add them, you can subtract them, you can multiply them, and you can divide them as long as you are not dividing by 0.